Welcome back to Linux Fundamentals, Module 2. In Module 1, we got the big picture. In this module, we open the hood. 5 parts: the kernel itself, Linux distributions, Linux compared to Windows and Mac OS, getting and accessing Linux, and finally package management, how you actually install software on a Linux server. By the end, you'll be able to describe Linux properly to a hiring manager and run real commands. Quick recap. Last module, a computer is hardware plus software. CPU is the brain. RAM is short-term memory. And SSD or HDD is permanent storage. The operating system is the dispatcher that makes hardware useful. Linux is free, open source, born in 1991 from a student named Linus Torvalds, and runs the majority of cloud servers and every Android phone. That was the foundation. Today, we build on top of it. Here's my promise for this model. By the end, you will be able to describe what the Linux kernel does, explain user space versus kernel space, define what a daemon is, and name examples like SSHD, list the popular Linux distributions, and which package manager each one uses. You're able to explain release life cycles, especially LTS and EOL. You're able to describe the 3 ways to access a Linux system: GUI, CLI, and SSH, and use both high-level tools like apt and DNF and low-level tools like dpkg and RPM. Part 1. The Linux kernel, a deep dive. In Module 1, we said that the kernel is the protected core that talks to hardware. Now we open the hood. What does the kernel actually do all day? What's the difference between user space and kernel space? And what's a daemon? That strange word you will see everywhere. The kernel does 6 big jobs. 1. Hardware communication through small programs called drivers. 2. Memory management. It hands out RAM to programs and stops one program from corrupting another. 3. CPU scheduling. It switches the CPU between programs so fast that they appear to run at the same time. 4. Interprocess communication. Self channels for programs to share data. 5. File system and storage management. 6. Security and permission enforcement. The kernel is like the dispatcher at a busy bus station. It allocates fuel, assigns lanes, connects passengers, manages the storage shed, and checks tickets at the gate. Linux doesn't appear from nowhere. It's Unix-like, a clean room re-implementation of an older operating system called Unix from 1969. Important nuance: Linux copies Unix design, not its code. macOS is different. It is a true Unix descendant through BSD and Darwin. In 1983, Richard Stallman started the GNU project to build a free Unix-like system. He wrote almost everything except a kernel. In 1991, Linus Torvalds wrote a small kernel as a hobby project. When you combine GNU's tools with Linus kernel, you get the complete free OS most people just call Linux. Technically, the full name is GNU/Linux. So here's a tip for you for the LPI. Stallman, GNU, Torvalds, kernel. This diagram is one of the most important pictures in all of Linux. You have seen them. I advise you to try to keep this in memory. 2 zones separated by a security boundary. User space at the top. That is where your programs live. We are talking about browsers, databases, web servers, and your shell. A crash on the user space only kills that one program. Kernel space at the bottom. Drivers, the scheduler, the memory manager, the network stack. A crash here takes the whole machine down. That's a kernel panic. The boundary is enforced by the CPU itself. If your browser wants to read a file or send a network packet, it has to ask the kernel through a system call. So you can always think of the user space as the hospital waiting room and wards. Kernel space is the operating theater. It's sterile, restricted, access only through proper admission. A daemon, pronounced daemon, is a background process. It starts at boot and sits silently, waiting for an event. When the event happens, it springs into action. You can think of a daemon like a security guard at the gate. It does not necessarily have to work all day. They sit, listen, and act when a car arrives. The most important daemon for cloud work is SSHD. Every time you connect to an EC2 instance, SSHD is a program on the other end picking up the call. Other key ones are HTTPD for web pages, crond runs scheduled tasks, syslog-D collects log messages, and there's a special parent called systemd. This is a process with ID 1, the very first program that runs at boot. API tip: most daemon names end in the letter D. SSHD, HTTPD, crond, systemd. Part 2. Linux distributions. So if Linux is the kernel, why do we hear all these names? Ubuntu, Fedora, RHEL, Mint, Rocky, Debian, open source, Amazon Linux. Those are distributions. Let's see what they actually mean and which ones matter for your career. A distribution, usually shortened to distro, is the complete package. It's a specific version of Linux kernel, plus a chosen set of libraries, system tools, a package manager, an installer, default applications, and a particular philosophy about how the system should be configured. They are all Linux underneath, but the experience on top can be very different. In terms of analogy, think of mobile money providers. You have MTN MoMo, Airtel Money, Orange Money, the same engine, different app and fees. Ubuntu is the most popular, one newcomers usually start with. Fedora is newer features, smaller market share. Open source is strong in some regions. The same engine, different experience. The Debian family. Debian itself is the original, born in 1993, famously stable and run by volunteers worldwide. Ubuntu is built directly on top of Debian. It took Debian's stability and added easier installation, a predictable 2-year LTS release cycle, and a friendly desktop. Ubuntu is what you will meet on AWS, on most company servers, in most online tutorials. If you are new, start with Ubuntu. Linux Mint takes Ubuntu and tricks it to feel familiar to Windows users. All three share the same package management family. Apt at the high level, dpkg underneath. When you learn the commands once, they will work across all three. The Red Hat family, RHEL, or Red Hat Enterprise Linux, is the gold standard for paid corporate Linux. Banks, governments, Fortune 500 companies pay Red Hat for support. When CentOS, the free clone, was discontinued in 2020, 2 new free clones were born, Rocky Linux and Alma Linux. Both are nearly bit-for-bit compatible with Red Hat Linux. Fedora is the cutting-edge upstream. New features get tested in Fedora first. Amazon Linux is AWS' own optimized distribution, often the default when you launch an EC2. All four use DNF at the high level and RPM at the low level. Just remember, Red Hat Enterprise 7 and older still use Yum. Same family, DNF just replace it. 3 families, 3 package managers. Think carefully about this mapping. It shows up on every LPI exam. Debian family, that's Debian, Ubuntu, Mint. They all use APT. Red Hat family, that's RHEL, Rocky, Alma, Fedora, Amazon Linux. They all use DNF, with Yum as the older name on Red Hat Enterprise Linux 7 and earlier. SUSE family use OpenSUSE and SLES, strong in the Europe, and uses Zyper. If you remember the family, the package manager is automatic. We'll mention CentOS, which was discontinued, but old documentation still references it everywhere. When you see it in a tutorial, mentally swap it for Rocky or Alma. Raspberry Pi OS is Debian-based, popular for IoT classrooms. Distribution lifecycle. Every distro moves through stages: development, beta, stable, maintenance, and finally EOL, or end of life. EOL is dangerous because every security hole stays unpatched. A server on an EOL distro is collecting unfixed vulnerabilities, like driving with expired brakes. LTS is long-term support. It is safe and you should pick it for any server. Ubuntu LTS comes out every 2 years and gets 5 years of patches. RHEL gets up to 10 years total. Non-LTS Ubuntu like 24.10 only gets 9 months. Fine for learning, but risky for production. You can think of an LTS release as the daily express bus you can plan a business around. EOL is cancel route. You turn up at the stop and no buses come up. Part 3. Linux is one of 3 big general-purpose operating systems, alongside Windows and macOS, but only one of them dominates servers. Why? Here's a quick comparison so that you can articulate the answer in an interview. Let's walk through the table. Cost. Linux is free. Windows is paid per machine. macOS is bundled with Apple hardware. Source code. Linux is fully open. Windows is closed. macOS is partially open at its core. Hardware. Linux runs on practically anything from a Raspberry Pi to a mainframe. Windows runs on most PCs. macOS only on Apple machines. Customization. Linux lets you change everything. Security. Linux has fewer attacks targeting it. And the big one, server use. Linux owns the cloud. Cloud connection. When Flutterwave processes your card payment, when Paystar sends a confirmation, when M-Pesa routes a transfer, almost certainly there's a Linux server in the path. That's why we're learning this. Part 4. Getting and accessing Linux. Now that you know what Linux is, how do you actually get your hands on one? 2 questions. How do you get Linux running? And once it's running, how do you get access to it? 3 ways to get started with Linux. Option 1. Install it directly on your machine. You download Ubuntu and replace your current OS. That's full commitment. It is like moving into a new house. Option 2. VirtualBox. You run Linux inside a window on top of your existing operating system. No risk, easy to try, like renting a furnished apartment. Option 3. You launch a cloud server like AWS EC2. You click a button and get you a fresh Linux machine in seconds, and you can access it through SSH. It's like booking a hotel room. For our course, we'll use option 3. That's how cloud engineers actually work. Don't reformat your laptop today, and do not try the VirtualBox. It requires some time. 3 ways to access a Linux system. 1. GUI, graphical user interface. You click with the mouse, you use menus, you drag windows. If you have been using Windows operating system, you will be familiar with this. It's very common on desktops. The second way to access Linux system is through the command line, CLI. Text only. You sit at the physical machine, you log in, you type, no mouse. It's common on servers without monitors. Part 3. SSH, secure shell. That's remote text access over the network and encrypted. The cloud engineer's daily tool. In this course, we focus on CLI and SSH. That's how cloud engineers work every day. GUI, graphical user interface. Visual desktop with icons, menus, and windows. On a Linux desktop, you can choose your desktop environment. That's the look and feel, like the example on the slide. GNOME is Ubuntu's default clean and modern GUI. KDE Plasma is highly customizable, looks more like Windows. SFCE is lightweight, is perfect for older hardware. Cinnamon is Linux Mint, default, and feels familiar to Windows users. Why servers keep GUI? A graphical desktop eats half a gig to a full gig of RAM and a slice of CPU just sitting idle. On a server where you want every megabyte going to the database or the web app, not to be drawing minutes, nobody is looking. That's why production servers run CLI only. CLI command line interface is a black screen with text, no mouse, no icons. A login prompt asks for username and password. Important, when you type your password, nothing appears on screen. No dots, no asterisks. This is completely normal. Linux hides your password so that nobody watching your screen can even see how long it is. Just type it carefully and press enter. If you try this and nothing appears as you type, do not panic. The keyboard is working perfectly. Linux is just keeping your password invisible. Cloud context, when you access an EC2 instance console through the AWS web interface, this is the screen you see. SSH, secure shell. This is encrypted remote text-based access to a server, the way every cloud engineer logs into Linux. How it works, you sit at your laptop, you run the SSH command, your laptop opens up an encrypted connection to the remote server. The SSHD daemon on the server picks up, remember SSD, the security guard at the gate. It checks your credentials. If you pass, you get a shell on the remote machine. From that point, everything you type is going across the internet, but encrypted. An analogy of SSH is like a secure mobile money transaction. You authenticate, the connection is encrypted in transit, and the agent on the other side processes your request. Real-world example, connecting to an EC2 instance. The very first step, you change mod 400 on your key file. This normally sets permissions to honor read only. SSH refuses to use a key file if anyone else on your machine could read it. That's a security check, not an annoyance. In step 2, the SSH command, SSH-I pointing at your key, then your user at hostname. The username normally depends on the distro. Ubuntu for Ubuntu, EC2-user for Amazon Linux, Rocky for Rocky Linux, and if you get this wrong, SSH will reject you even if the right key is present. In step 3, the first time you connect, SSH asks if you trust this server. Type yes once, it remembers. Step 4, you are in. Your prompt has changed. You are typing on a machine that might be in Cape Town, Frankfurt, or Virginia. Step 5, when you are done, you type exit. I'm going to do a short demo on how to connect to another server using SSH. So I have to go back to my Ubuntu server. This is my Ubuntu server running in the cloud. I've created another server that uses Amazon Linux image. And what I'm going to do is to connect to that server from this Ubuntu server with SSH. The first thing I have to do is I have to check if the key associated to the Amazon Linux server is present in this machine. And I've used a command ls. We're going to cover commands shortly. But this shows that that key is present. So the next step is I'm going to ensure that I set the permissions of that key to be 400. We're going to learn about permissions and sudo shortly. So I'm going to ensure that I execute this command on the key and I hit enter. So the next step now is I'm just going to do SSH-I. I'll point it to that key and the username when you are connecting to an Amazon Linux server that uses Amazon Linux image. It's ec2-user. And then I'm going to do add the host, the IP address or the host name, but I have the IP address here, which is IPv6. So I'm just going to paste that IP address. You can see the entire command. That's the IP address that I've spelled out here. And if I hit enter, since this is the first time I'm connecting to that server, I see a question here. Are you sure you want to continue connecting? If I type yes, because this is the first time, this will not happen again when I next connect. So after I type yes, if you look at the bottom here, it says ec2-user at. It is completely different now from what I had earlier here. This is the Ubuntu server, and while sitting at the Ubuntu server, I've run an SSH command, and I'm able to connect to a complete different server using SSH. So I wanted to show you how this works on my server. So let's proceed. So to log out, before I go to log out, I just type exit. If I type exit and hit enter, if you notice, I come back to the Ubuntu server. It shows here logout, connection to this is now closed. So that's how to log on to a server using SSH and how to exit from it. Okay, thank you for watching. Let's continue. Three ways to log out. I've shown exit, or you can just type logout. Another way to log out is just to press Ctrl+D. On a shared server, leaving your session open is like leaving a kiosk unlocked. Anyone walking by can run commands as you see your files. So always log out when you are done. Make it a reflex. Part 5, Package Management. The most hands-on section of the module and the section that's tested heavily on the LPI exam will cover what a package manager is, the high-level tools, apt and DNF, and low-level tools, dpkg and RPM. A package manager is a tool that installs, updates, removes, and tracks software on your Linux system. The packages themselves come from repositories. Those are central servers that hold trusted, verified, rebuilt software ready for download. Package manager plus repository, that's the system. Analogy: Linux package managers are food delivery for software. You don't drive to the kitchen yourself. You open the app, type what you want, and the service brings it to your door. It handles dependencies, handles the install itself. Without a package manager, you will hunt down the right file on some websites, check the version, and install the dependencies one by one. It is painful and risky. LPI tip: a repository is a curated source, software that has been tested and signed. apt and DNF are the two main high-level package managers you use every day. apt, Advanced Package Tool, is for the Debian family, Ubuntu, Debian, and Mint. DNF, short for Dandified Yum, is for the Red Hat family. RHEL, Rocky, Fedora, Amazon Linux. The commands are similar enough that you can switch between them. apt update or DNF check update. Refresh the list of available software. apt install gigs or DNF install gigs install the software gigs. apt upgrade or DNF upgrade patches what is installed. apt remove or DNF remove uninstalls a package or software. LPI tip: apt-get is the older DBoss form of apt. Both still work. Yum is the legacy Red Hat tool. DNF replaced it. Both still exist on older system. So let's try some practice again on our system. I'm going to go back to our machine, and I'm going to open up a second window. So this is quite interesting. I've logged to the Ubuntu server twice. That's possible to do so. We'll come to understand how that works. So I have the Ubuntu server. I've logged onto here twice. So what I'm going to do is simple. I want to log on one of the servers, SSH. I'm going to log onto the Amazon, the server that has Amazon Linux. All right. So I have, as you can notice, two different windows. One in which I've logged in with EC2 user, and you can recognize that that's the Amazon Linux, and one that has Ubuntu. You definitely recognize that that is the one that has Ubuntu. So they both use different package managers. So on Ubuntu, I'm going to do a refresh of the package list. So if I want to do that, I do sudo apt update. That's the command I run, right? It's going to go ahead and refresh the package list. And if I want to do the same kind of command for if I'm using Amazon Linux, the command I run is sudo dnf check update. And I hit enter. Right. So after running the command, it can refresh the package list and you can see the updates that are ready. And if you run it the second time, it just tells you it has just done so not long ago. So that's the first way to refresh the package list or to check for updates. Now let's assume I want to install a package. If I'm on the Ubuntu server, so that's the next thing we want to show. Now, if you want to install a piece of software on the Ubuntu server using the apt package manager. So you run sudo apt install. I'm going to use things here. I see I need to bring this closer. Right. So let me hit enter. So it's running. It was fine. It finds the package or the software and it asks me, it tells me the download size, the space needed. Should I continue? If I go ahead and give a Y, it will go ahead and install the package for me. That's how to install software if I'm using Ubuntu. The command is sudo apt install gins. That's the name of the software. If I want to install a similar kind of software on Amazon Linux, I'm going to run sudo dnf install, and I'm going to use HTTPD similar to gins, and I'll hit enter. You'll learn about these tools later or these packages later. So the key thing is just to show a demo of how to install software. So after running the command, it goes ahead and tells me it has found the package. It knows the size. It asks me, is this okay? I say yes, and I hit enter. It's going to run and install the package for me. So that's basically how to install a package. What if I want to remove it? How do I do that on Ubuntu, right? Or let's start with Amazon Linux. Since we're there, I just run sudo dnf and I just say remove. I know the package name already, and I hit enter. It's going to tell me it's going to remove the package. But you see, it says 13 packages. I'll explain that later because there are some dependencies that were installed as well, right? So when you want to install a package, it installs some dependencies. So it's going to remove all of those dependencies as well. And you're going to gain 7 megabytes here. So the amount of space that's going to be freed from this on installation is 7. So I'm going to type yes. And I'm going to hit enter. It's going to do that and it will tell me it has removed all of them and it's complete. If I want to run the same command on Ubuntu, how do I do that? I want to remove the package and install earlier. That's sudo apt remove. I'm going to also say guilds and I hit enter. It tells me it's going to remove. It asks me, is that what I want? I say yes, and I hit enter. It's going to run and ensure that it is removed. So that is how you can check for updates on Ubuntu as well as on Amazon Linux using the two different package managers. And that is how you can install as well as remove software. It's really that straightforward. Thank you for watching. Let's continue. Now, the LPI topic many students miss, low-level package tools. Underneath apt, there's a lower level tool called dpkg that actually places .deb files on disk. Underneath DNF, there is RPM that installs .rpm files. The high-level tools handle dependencies and repositories. The low-level tools just install one file you give them. No questions asked. Analogy: apt and DNF are full-service food delivery. dpkg and RPM are buying components yourself at the market. Useful when someone hands you a single .deb and you want to install it directly. LPI commands you must know: dpkg-l list install packages. dpkg-i install a .deb package. rpm-q a query all installed packages. rpm-qf query which package owns a file. Keep those in mind. Now, let's look at another quick demo to see how the low-level tools work. So I'm going to go back to my two screens here. You have the one where I've logged in with Ubuntu and the one where I've logged in with EC2 user. You identify the one with EC2 - user, that's using Amazon Linux, and the one with Ubuntu, of course, is then using Ubuntu image. So if I want to look at the list of packages installed on the Ubuntu server using the low-level tool, that's dpkg. I just type dpkg-l, L is there. It's listing, it's going to list the number of packages or the software that has been installed on Ubuntu. So if I type that command and I hit enter, it's going to run an entire list here, and I can scroll all the way to the bottom to see all the packages installed. So at the bottom here, it finishes. You can see I have the Ubuntu list coming on right under here, right? So the command, again, nothing to worry. You just want to know what's the command to list the packages or the software installed on this Ubuntu server. Now that we have done that, let's go ahead and look at how do I do that also if I'm using the Amazon Linux here. So to do that, I use the command rpm -q. Q is for query, and a for, I just look at it as all. So it's querying all the packages, all the software that's installed on this server. So I hope you can easily remember reading it like that. rpm -qa, where q is for query, a is for all. If I hit enter, it's going to list all the software that has been installed on this server as well, right? So the command here, rpm, when you are working with Amazon Linux, this is the other tool that you use. It's going to be able to show you a list of all the software installed on this server. What happens if I have a file and I want to figure out which package belongs to that file? Let's say I want to know which package belongs or which file belongs to a particular package. If I'm on Amazon Linux, I can do rpm, and this time I use query. Query again is for query, and I use f. That means I'm specifying a file. And here, let's say I want to know which package actually on the file that looks like this. If I hit enter, going to tell me the package that owns this file. That's the package, right? So that's how if you see a file and you want to know which package owns it, you can use RPM minus query, you are querying, and F, you are querying the file. What if I want to run a similar command on the Ubuntu server, right? So I'm going to come on the Ubuntu server, I'm going to type on clear so that I can see the clean environment. On the Ubuntu server, I'm going to use dpkg. That's the command we're using, but in this case, we are using S and then usr/bin. I want to query the same file, type an ls. And if I hit enter, you notice that that is the package here. The package here owns this file. Again, that is another demo of how to use the low-level commands. Practice makes perfect. So Linux, you don't learn by watching, so keep practicing. And if you have questions, make sure that you are asking them in our forum or the Discord channel. Thank you for watching. A recap. So what can you do now? The kernel does 6 jobs: hardware communication, memory management, CPU scheduling, interprocess communication, file system, security. User space and kernel space are walled off. That's why your browser crashing doesn't reboot the whole server. Daemons are background processes: SSHD, HTTPD, crond, systemd, names that end in D. Every distro maps to a family and a package manager: Debian, apt, and dpkg. Red Hat, DNF, and RPM. SUSE uses Zyper. Pick LTS within its support window for production. That's long-term support. And you can SSH into a Linux server anywhere in the world. That's a RHEL Cloud Engineers Foundation. That brings us to the end of Module 002. Before you move on, go ahead and complete all the remaining module activities. Walk through the hands-on lab, answer the knowledge check questions, and attempt the certification style questions. Take your time with those. They are there to make sure the concepts have landed, not just been heard. Make sure you also use the Kimo AI assistant. It will help you clarify any doubts. Bring your questions to the discussion forum or to the Discord channel. And when you are ready, move to Module 003. In Module 003, we shall get our hands on with the Linux terminal, meet the shell, and start working with system logs. Bring your EC2 instance and a curious mind. As always, let's rule the clouds. Murakoze, Medesa, Deriven.